Greetings. Today's lesson will be looking at the manipulation of sovereign downloaded Excel data for better analysis. Firstly, you need to use your browser to locate sovereign. I'm going to Google it. Here it is. It pops up with showing the map of Southern African regions, and then with the legend right there, blue one indicating stations which are offline, and then we've got yellow, temporarily offline, the likes of Central University of Technology, and then yellow, or rather orange, the stations that are active. So look at Stellenbosch. Give us a nice picture of Stellenbosch. We can also see what Southern it means. It's an acronym for Southern African University Radiometric Network. Not only about solar resources. There are other things which you will be able to get there. Those things are listed in here. We've got batteries, we have got air temperatures, and so forth. Now, let's go to 2022. So there is no logic in choosing that. Well, just spring weather. Interested in taking it. We'll look at the 24. And yeah, and we go again. 2021. We look at the 24. So it's 24 hours. We want it minute averaged. And once our selections are okay, we download and we choose a folder where to save those data. Well, I need to have it in a place where I will be able to record. So we go to UJ, and this is a research data. I'm gonna pick research 2022. Now, okay, give it a user-friendly name, Stellenbosch. Was 2021 09 24 radiations. So when radiations taken on that day was Stellenbosch, I save. The file is there. We can try to show it in a folder where we downloaded it. It is right there. Let's open it with Excel and see what's gonna come out. Go directly to Excel, we'll open. Now it came up with something unrecognizable. So the way around that is to just say new. And instead of using open from the folder, you open it from Excel. That is, we now might have to close that. So the old one is there, not there. Let's do it again. Now, it came up with a box which enable us to format our data. So it's delimited, and we've got headers, and we proceed to the next one. How do we separate our columns? We're gonna use semicolons to signify our column. We're gonna use, it doesn't do anything, let's say comma. It recognizes it. And then from there, space. Let's see what was gonna come out with the space only. You need to know your data, how it's separated. So comma. Well, it looks like more or less it on the preview. So we can go finish. One thing which is disturbing here, we've got a time here. It's supposed to be time, or this is supposed to be date. We've got a mix up here. Date, date. Okay, you can manually fix that. And this is supposed to be time. Right. So we fix that, and then that one, we can make it. Maybe we can look at the end. At the end of it, if the headings are the last item, it does have a heading. So minimum, it does have a heading. There might have been a repeat right over there. So you fix the headings accordingly, and kilometers per kilometers, kilowatt per meter squared. That's like a unit for radiation. We'll put it down, kilowatt per meter squared, right? And then there, it's watt per meter squared, watt per meter squared. It's fine. And then same thing there, watt per meter squared. And then this one's degrees. DNI, we're not sure if we're gonna need, we leave. Delete that one. What we have? No, we don't need. Degrees, we don't need. Wind direction, we don't need. What is this? Wind direction again, we don't need. Delete that one. We're gonna look at what BP is. Let's just have a look, stretch it up. But those reasons were occurring at about early in the morning, so there was no sun. It will never hardly gonna be the sun. UVA, those things we don't need. We need battery. We can leave. Those ones which are applicable, not applicable, we can't read anything from there, so we delete. So the second step after download and formatting your columns is to delete things which you don't need. Right now, we progress with this. We don't know what time is the sunset, though, in Cape Town. And maybe to be safe, we can start this from 5 o'clock in the morning. 5 o'clock in the morning. Maybe now, let's just delete the top. Rows and work with only one. So this is battery. I can remember that voltage. Now, we freeze the rows, the top ones. We go view, freeze top row, so that they stay there. When they shouldn't like move. And then we look for, as they we're gonna start at 5 o'clock. 5 o'clock, we start there. And then we can go to 5 p.m. Right. So starting from 5 o'clock, it goes onward. We're gonna go to, let's see there, in case the sunset late. But we can like go up until 7 p.m. We make sure that everything is covered. So we go there. Different areas have got different sunset, they've got different sunrise. So uh, I suppose all that time gonna cover everything. Now we have a look at the values there. 626, we start getting values there. Before that, there were no values. But this one, it looks like it has been there all along. So it won't help. We need to delete. Right. What per meter squared, that one was 0 all the way. Delete. Right. It looks like during that date, we never have a proper. There's nothing which is convincing enough to be the sun's radiation. So it's difficult to challenge that unless you have a full weather map on Cape Town. What you can do, we can try to look for the summer one, midsummer. Hopefully, we're gonna come up with something. But remember, in summer it might rain, so we just change this to December. For December and see. We obviously need to change the date there, so that will be on December. We save. Mhm. We open again. Browse it. Okay, now we have a task to locate it again. So that's one. We need to take all files. Remember that. And then let's see today is that this one, the one for December, mid-December. Let's see if they're gonna be these differences. My data has had us delimited, and then okay. Next, separated by space and comma. We finish. Right. Maybe before we do some editing, we need to go and look at around midday, which one shows that if the weather was good during that particular day. They say this one 0000 makes sense, but there that one start reading values at around 345 doesn't look to be the one. These are the ones that we start giving values there. So we can like somehow start from the last 0. We move up, we delete the rest. So that clearly has got nothing to do with solar. Yeah, right. Then these values which exist after there, we still have to go through them. So we check the one which will drop at 0 right late in the afternoon, and then that will be somehow solar. So which one there? This ones at that's late. Okay. The best way, it will be to freeze the top ones. Well, to freeze, you go view, and then you look for freeze panes, and then take a proper option there. Freeze first color, freeze panes. So we want to freeze the selected. Let's suppose it's freezed. Let's just check. Yeah, it's freezed. What we need. Those average we don't want anyway. So we go. Where this one's changing to 0. So those values they changes to 0. Let's have a closer look what it is. DNI changes to 0. And this and that and that. So there's other ones didn't change to 0. So we can delete those ones there, except for the battery. Right. We delete that. And we delete that. We delete that based on the fact that the units has got nothing to do with solar resources. We know the unit for solar resources is in watt per meter squared or kilowatt per meter squared. So these are more likely to be. But now we've got values which exist even after late. So this one, which exists late, let's delete. We just have to leave the last 0, because obviously your values will drop to 0. This is the last 0, and then we delete what follows, and that's it. We deleted it. Now that one not applicable. There's nothing gonna do with not applicable. There is no data supplied, so it doesn't have any information for us. Now, all right. Well, what we're gonna look at now, this one, there are values which are high before even we start reading. So we can delete that. And then we've got this one, which has got seem to have a wrong unit. We've got time as kilowatt per meter squared. So that's time. We amend that. Let's look at what is closer there. We can see around midday, which is 12 o'clock. We expect a value of around 1,000 kilowatt per meter squared. Midday. That is the maximum solar you can have. So, and we know you have it at around 12. Let's see what's happening this around 12. The values seem to illustrate a nice clear sky. So that is this ones. You see, they look to more comply, but let's stretch it and see what it is. So if we look at this one, it's a DNI average. We're not sure what it average, but it looks like it's the one which resembles things nicely. Perhaps you might be interested to see what DNI is, and we're gonna have to ask our brother here, Google. and then to tell us what DNI is, because it looks like the one which is more promising in that instance. I'm not saying the other ones are far from going in proportion with the sun, but with proper analysis, it looks like it's more closely aligned to what we want. Solar, DNI, direct normal irradiance. Sun is approximately 6, okay, per day. Oh, so that looks like a peak sun hours. Now, let's say per hour. Per hour. Okay, it looks like this is an average for a day, which it might not suit properly for that. Unless, let's see the other ones. Okay, that might be the one to use. It might have been worked out hourly, because if you see that those units are far more than 6. So we take the DNI and then let's delete the rest. Okay, let's leave that tracker. We're gonna go and have a closer look at it and see what it gives. We're striving to find what better represents the solar radiation. So, right. And bear in mind that the maximum solar radiation pattern is 1000. Okay, it looks like now we're gonna settle for this one. Tracker, this one. That it looks like it is a clear representation. So that will be, we can remove DNI, take a break DNI and insert a column right there. Right. And then where we're gonna see solar or irradiance, rather, in percent. These values end at 1000. The maximum is 1000. So now, if the maximum is 1000, how do you convert it to percent? We divide by 10. That's a maximum, ideal maximum. So it's equals to this divide by 10, and then this. I'm not clear what's not giving me this thing, a proper value. Let's do it again. Equals to, let's start by that, and see, divide by 10. Okay. All right. So let's see what's that. What format is this? That needs to be a number, 2 decimal places. It's fine. Insert formulas. All right. The problem we're having here is this thing here. Is dot for comma. This version of Excel doesn't recognize that. So we need to change this to our commas to what this thing can. So to do that, we just select all. We go and search. We replace. We're gonna replace dot with the proper comma in all appearances for our selection. So we replace all. So that's it. I think now more likely gonna take the formula. So let's do it again. Equals to this divided by 10. Right, there we've got values. And we can drag our formula down to cover what everything, what's there. Right. Mm. There are places which this thing never replaced. So, let's just do it again. We still have garbage elsewhere. So we replace, replace all. Yeah, there were still values which were left unchanged. We close. So now suppose I think we have the right values. Now, if we go with our irradiance, we work with it, we'll see that they start at 6 o'clock, right? Makes sense, right? So we delete the rest. We're scaling it down. And then precisely, where do they end? Oh no, we omitted our 0. The first 0 must leave. All right. Precisely, where does it end? And we start getting zeros. All right, the last 0. That's what we're gonna keep, which was at 1959. Makes sense, pretty much more sense. And then we delete. Right, once you have that, you are able to plot against time. So what we do is we're gonna remove what we don't need. That what per in, we can move it there. Double per meter squared. I'm not sure if our units are still right though, because on changing format, we saw some other title shifted. But anyway, it won't make us lose the instance of our illustration. So this, let's say record number, which was supposed to be time. Time, right, it's fine. And now the radiance is moved down. Right, there we go. And that one is better. I remember that, right? Delete the top one. Let's see if it's still, yeah. There we go. It's still frozen, the top one. So now we can plot our irradiance versus time. We just select. Maybe to be precise, we select, write those values, just only those values which we need, without going to, we don't need date. We know the date is one day. It was Christmas Eve, right? So this we selected, we go insert. You check right on scatter if there's anything which gives you what you need. So let's see. Check the format, just a clean graph. We insert. It looks like it's inserted somewhere. Yeah, but this is not clean. We're expecting a pure white. Let's just check this one out. That one, yeah, it looks more clean. That one, look, more clean. There we go. So you can see our percentage ended 100%. The sun radiation, it was like you had partly some clouds which were coming now and there. Nevertheless, you can change your scale now to cover only what you need. So you right click that and say format axis, and that's gonna be a try and error. Because if you check there, on the axis, this one, 0.2, 2.04. So let's say 0.3 and see what's going to happen. We didn't have that much of a change. Let's reset. All right. 0.2, 2.0. Okay, so it's 0.03. Oh, we have to read what we're doing. That's not what that is. It's what we want. That's what we want. The minimum. The minimum is not 0. And it's the maximum is 1. So the minimum is something, any number there, maybe 0.05. Let's try that. Shifting it 0.1. Let's see. Shifting it 0.5. Too much. 0.3. Too much. 2. 2, 1. 2, 4. Right. So there it is. And then at the end, we've got extra there. So we can say 0.7, maybe try that. It's too much. 8. Too much. 8, 5. Right, there we go. So it covers the areas which we need. We can do the same. It's showing irradiance in percentage. So this is irradiance in percentage. I would like to move it to the vertical axis. Right. So we can do that the same here. And then format axis, 120 is too much. We don't go there. So maybe say the maximum is 1. We don't have negative values. 0 will do. 0. And then we end at 150. 110. 110. Right. So there it is. We have a nice chart which indicate our solar radiations. But midday, you see that it's towards maximum, though there have been like clouds which were interrupting. So you managed to successfully plot the graph to indicate your solar reception for that particular station. So try it for other dates. And that's all I have to give to you folks. And thanks for listening. Bye-bye.